Alright, welcome back everybody. In this video we're going to look at some examples from the normal probabilities lesson. We're going to start and we'll just look at examples 1 and 2 in this video, and then we'll handle the rest of the examples in the next video. So the first concept that was introduced was the idea of a probability density function, and you can read through the content prior to example 1 in order to establish, kind of your baseline for this material. But this first example is going to be reasonably simple for us. The probability density function for the amount of time spent waiting in line at the counter of a particular store is given there. There's no probability for a time value of less than 0. You can't wait in line for less than no time. And then it is 0.1 e to the negative t over 10 for all values of t greater than or equal to 0. Excuse me. We want to find the probability that a person's going to wait in line for between 3 and 7 minutes. So in order to do this, all we're going to do is we're going to integrate the probability density function from one end of this time interval to the other. And so I'll break out my handy dandy calculator. And again, I don't need my calculator to do this one, but in the effort of saving some time potentially, I'm going to use it. And there's my probability density function, and we're integrating 3 to 7. And we find that this is 0.24423. Which represents a probability of 24.423% that someone will be waiting in line between 3 and 7 minutes in this particular model. Alright, then there's some more narrative about the most useful kind of probability density function being the normal curve. We've all heard of the normal curve, I hope, by this point in time. In order to build a normal curve for any characteristic, I need to know two things. I need to know mu, which represents the mean of that characteristic for the population. We frequently approximate it using the mean from a sample, which we notate x bar. And the other thing we need to know is sigma, which represents the standard deviation of that characteristic for the population. We frequently approximate that by using the standard deviation from a sample, which is notated s. So if I have a particular characteristic that I know is normal, we're going to find the probability of various outcomes. Sorry, my voice is struggling right now. We're going to find the probability of various outcomes by using the Gaussian formula, which we see at the top of the next page. Okay, the normal probability density function, often referred to as a Gaussian curve for a population with mean of mu and standard deviation of sigma, is this function right here. And whenever we know that a population is normal, we can use it to calculate probabilities of various characteristics. Let's look at example 2. For human population, IQ has a mean value of roughly 100 and a standard deviation of 15. We're going to find the probability that a person's IQ is between 120 and 140. And so we're just going to integrate the probability density function for IQ from 120 to 140. And we're going to write that probability density function by substituting the sigma value that we have and the mu value that we have into this formula. The first portion of this I can leave out in front since it doesn't contain the variable x. So I'm going to have 1 over sigma, which is 15, times the square root of 2 pi. And then my integrand here is going to be e to the opposite of x minus mu. Mu is 100 here. Mu squared over the quantity 2 sigma squared. And now that I've got that all set up, I can go ahead and calculate probability thusly. So I've got 1 over quantity 15 times the square root of 2 pi times the integral of e to the opposite of the quantity x minus 100 quantity squared divided by quantity 2 times 15 squared. Close that quantity, close the exponent with respect to x from 120 to 140. And we get that the probability here is roughly 8.738%. Wow, forgot to write my 8. 8.738%. Okay. Now, well, it's important for us to understand, I think, the normal probability density function and where it, how it's used and where it's coming up with numbers from. We're going to actually use a little calculator shortcut to calculate probabilities like this in general. So if I pull up my calculator, underneath the distribution menu, which we get to by hitting second vars, there are two commands, the normal probability density function and the normal cumulative distribution function. We're going to use the normal CDF command here. And the syntax that we use when we're finding the probability of something is we take the low boundary of the interval that we're looking at, and then the high boundary, and then we enter the mean, which is 100, and the standard deviation, which is 15, and it calculates that same 8.738%. And undoubtedly your calculator is using this formula to generate this particular cumulative distribution function and the probability that is associated with it. Alright, that's the end of this video. Come on back to see the second half with examples 3 to 5, and see you guys next time. Have a great rest of your day.